to data science. Now, as you all know, that data science is basically is giving answers to our questions, right? So different people, to different people, data science means different things, right? So it is using this data, the data that we're having in our surrounding. If we are using this data, if we are analyzing this data, or if we are concluding, getting knowledge from that data, okay, or we are coming up with some answers with that data, this is basically the data science, right? So this is a very broad field, not a narrow field. So this field, it is broad, that's why its definition is also broad. Okay, so in a single line I can say that data science is using data to answer different set of questions, right? Now there are a number of questions that we are having. For example, if I want to predict today that what will be the temperature or what will be the climate in coming days in Missouri, that again we can find the answer to this question with a certain data set, the data set of climatic data set of Missouri over the last 10 years or 20 years, right? Or if I want to know whether or not India will win the match or not win the match in England. Okay, that again we can conclude from data science, right? So anything that we want to have answer, right? That answer we can get from this data science. Okay. Now, as I said, that it is a broad field. So this field includes programming. This field includes mathematics, statistics. Okay, for predictions, for classifications. Right. So the person who are working, the data scientist is equipped with all these three things in his mind, right? In his or her mind, mathematics, statistics, as well as programming skills. Fine. So narrowing the definition of data science is a multidisciplinary approach, okay, to extract knowledge from large and ever increasing volumes of data collected from various sources. Okay, so these days you know that our embedded field has achieved quite a good growth in last 20 to 30 years. We are working on nanochips, microchips, right? So with these high-end controllers and processors, as well as with high-end sensors and actuators, it is now possible to get data from everywhere. Okay, these IoT devices, your sensors, they are capable of gathering the data. Data loggers are there, and with that data, we can apply this data science to extract something from it, right? So data science involves preparing data for analysis and processing and presenting the results to reveal patterns and enable stakeholders to draw informed conclusions, right? So the stakeholders that we are having, anyone who is related to that particular field, right? The stakeholders, fine. So with that data set, we can find out, we can get some conclusion, right? For example, these days students are basically inclined towards computer science as compared to core engineering, mechanical, civil, electrical, electronics, right? So we can have a data set from last 10 to 20 years from different universities across India as well as across the world, and we can find out what is the main reason why the people are not taking, students are not taking admissions in different core engineering backgrounds, right? So this all, anything that we want to get knowledge, anything that we want to conclude, okay, so in, if I say this, if I take this problem, that why the students are not inclined towards core engineering, so the stakeholders are the students, the faculties, the parents, that or the companies that are related to that institution or the academic institution, right? So they want to know why, what is the reason why the people are not moving towards core engineering, right? So this conclusion, this knowledge we can extract from the data set, right? So anything that we want to know, any answer that we want to get that we are not getting, okay, that we can get through this data science, right? That's why this field is growing vastly across the world, right? Now, if I talk about the cycle, data science life cycle, right? So it includes, first we need to collect the data, right? From different sources. If I say in electronics, we are having sensors. From those sensors, we can get the data from your ultrasonic sensor, or your from camera, right? We can get the from camera we can get the images. Okay, we can get the videos, right? So we can get the data from different sensors, different electronic components, right? Now once we get the data, then what is the next thing in data science life cycle? Next thing is cleaning the data. So we need to clean the data. Once we have cleaned the data, or it is data preparation, then what we will be doing, we will be implementing different set of algorithms, right? Algorithms which will be used for solving a problem, right? For example, if we need to do prediction, then we can do the predictions. If we need to do the classification, then we can do the classification, clustering, data mining, or we can nothing else. We are simply extracting knowledge from the data. So different set of algorithms, artificial intelligence, machine learning, deep learning algorithms are there, which are basically extracting knowledge from the data, right? So that is basically data processing. Once the data has processed, then we have to visualize the data, means we have to present the results in a certain form with which we can build some conclusions, right? So that is data visualization, right? For example, in the form of if we are doing predictions, we can have some errors with us, right, with which we can analyze that this is good or wrong, right? Or if we are doing some classification thing, then we can build some confusion matrix, or we can build some we can have some numerical parameters, for example, recall, precision, right, F1 score, log loss, with which we can do some we can build some conclusions, right? So once the data has processed, then we have to visualize the result in a certain form with which we can build some conclusions, right? So this is the data science life cycle, which includes which starts from the starting point, means getting the data, then preparing the data, because data that we are having, that data is having outliers, that data is noisy. Okay, so first thing, after collecting the data, we need to clean it, right? Once we have cleaned it, then we have to process it, and at last we have to visualize it, right? So this is the data science life cycle, right? Now we are having, as I told you, that we are having different sets of data, right? So data can be of two types basically. First is basically the qualitative data, means the data that cannot be measured, right? It is basically presenting the quality of the data, right? For example, if for example in our institute UPS, we are having grading. Okay, we don't give discrete marks to the students. The students are having grades A plus, B plus, C, or fail, right? So this is basically the qualitative data, right? The data is not measured in some numerical value, it is basically presented in the form of a categorical value, right? So this is a qualitative data, which is basically representing the quality of that information, right? Now if I say the second type of data is basically the quantitative data, right? So quantitative data is basically data which is basically is measured in terms of a quantity, right? For example, what is the marks the student got in the exam out of 100, 10, 20, 30, 40, 50, 70, 80, right? That is a quantity that we are measuring, right? Or the height of a person, or the weight of a person, right? So that is a quantitative data. So these are the two basic data types, okay, that we encounter, right, while we are working on in data science, right? That is qualitative data and the quantitative data. Fine. Now why this field has experienced such growth, right? That is a main question that comes to our mind, right? It is because of the wide availability of data. According to the records, this data I have got from your Google only, right? That it has been estimated that 1.2 gigabytes worth of information is currently available, and this number is growing exponentially. Okay, so day by day, the data not connected, right? People were living isolatedly. Now all the people across the world, they are connected. If I am here, I can talk to my friend in your USA, anywhere, okay, through my WhatsApp call, right? So all the people are connected, right? Or we are having number of good sources are there, data centers are there where the data can be collected, right? So all the data that means the data, for example, your call records, everything is stored in the data centers, right? So from that data centers, we can get the data, right? So at present 1.2 zettabyte, right? Zeta stands for 10 to the 21 zettabyte worth of data is available. Okay, and this data is growing exponentially. All of you have heard of the number of companies are there. For example, Amazon Web Services, right? Your IBM, okay, or your Microsoft, okay, Azure, okay. So they are having the data. They are having the clouds. Okay, clouds means the data centers. So in these data centers, all the data is being stored, right? So in United States, in India, everywhere, these big giant companies are having the data centers where they are storing the data, right? So that's why, because in this digital world where we are using digital equipment, digital services, right? So with this connected world, globally connected world, we are having this tons of data with us, right? So once we are having a data, we can play with this data, and that here comes the role of data science, where we can play with this data, we can work on this data, and we can extract the knowledge from this data, right? So this is the reason why this field has experienced such growth. Fine. Now, till now, I have discussed with you about what is data science, what is data science life cycle, okay, and how, what is the reason this field has shown experienced such a tremendous growth, okay. Fine. So all of you have, I think you have understood that we are getting the data, okay, we are cleaning the data, we are processing the data, and we are visualizing the results, right? So now the your data processing part, okay, that is a critical part, because with this all the parts are critical. If I say that your data collection is also a critical thing, right? Data cleaning is also a very important thing, right? But how we are extracting knowledge from that data, okay, how we are finding out the things from that data, okay, how we are extracting golds, okay, gold from that data, right? So this is basically done through the algorithms, okay. So your AI, machine learning, deep learning algorithms play a critical role, okay, in data science, okay. So before going to your machine learning, deep learning, I would like to introduce you all with AI, right? Because every day around our society we heard this term artificial intelligence, artificial intelligence. Whenever we heard of Siri, okay, your iPhone app, or whenever we hear your Google Duplex or your Google Assistant applications in our mobile phones, okay, or whenever we type something on the Google, okay, automatically the recommendation, automatically the thing that you want to type, it all automatically it comes. Whenever you are uploading a photograph on Facebook, already the friend who is in your friend list, if he or she is present in that photograph, his name appears, right? So this, how it is done, what is the basic fundamental, what is, there is something, some algorithms are running in the back end, right? So this all is AI, right? So AI is a very bigger umbrella, which is a very vast field, okay, which includes a number of subdomains, or which includes number of verticals under it, right? So before discussing MLDL in detail, let's discuss AI. So as you can see on the screen, AI is basically built from two words, okay, and those two words are artificial and intelligence, okay. So artificial is man-made, okay, the thing that is being made by man, okay, that is not original, that is not real, right? And if we say intelligence, intelligence is the ability with which a human is learning a thing, okay, because as you know, the intelligence is there in the human, right? So with this intelligence, human is what the human is doing, human is learning new thing, human is thinking, okay, and accordingly human is responding, right? So this is the intelligence that the human is having, right? Now if the same intelligence is being given to a machine, right, in the form of programs, okay, then it becomes artificial intelligence. The intelligence, the our brain is basically comprising of neurons, okay, that I will be talking when I will be discussing with you neural networks, right? So we are having neurons in our brain, and all those neurons are interconnected. We are having millions, trillions of neurons in our brain, right? And whenever a child grows from childhood to adult age, right, or to old age, then those neurons day by day they basically take some knowledge, okay, they take the synaptic weights grows, okay, and they basically learn new things, okay. This is nothing, this is plasticity, right? Learning from the environment, right? So whenever a person learns from the environment, and once the person is learned, then person, if suppose the person is for example, I am having a kid at my home, okay, whenever I told to my kid that this is good, this is bad, this is good, this is bad, then ultimately for a certain new thing, okay, my kid understand that this is good or this is bad, right? So this is not, this is what, how it is happening, okay. It is happening with the intelligence that the kid has acquired over the past few years, right? So this is the intelligence, means the thing, the learning phase is going on, right? With that learning phase, the kid is thinking, okay, how it is happening, and accordingly kid is responding to new things, okay, that this is good or this is bad, right? So this is the intelligence that the human is having. Now if we are giving the same intelligence, okay, to a program, to a machine in the form of programs, right? We are writing some algorithms, we are writing some programs, and with that program the machine is doing the same thing that the human is doing. So this becomes your artificial intelligence, okay, the intelligence, the man-made intelligence, right? So with this intelligence the human is having the ability to solve problems rationally, means logically, okay, and accordingly the human is acting like the humans, okay, sorry, the machine is acting like the humans, okay, but the machine can't have the emotions, okay. Machine is we are having the human is having emotions, the human is having intelligence, and with the combination of emotion and the intelligence, right, the human is taking the decision. But here you can say that machine will not take the decisions emotionally, machine will take the decisions logically, okay, with the brain, not with the heart, right, because we are only providing it the your intelligence only, right? So this is your artificial intelligence, right? So nothing, don't fear from this term. You all from, most of you are from computer science background, you must be having good knowledge of AI, right? I am from electrical electronics, but I am teaching this subject in our university. So you better know this thing, AI algorithms, you are working on it right now. But what I want to clear out that this term AI, okay, we daily hear this term, right? So this is not a very big term, okay. This is only simple thing, a man-made intelligence that we are giving to a machine in the form of algorithms, programs, right? Now this if we go into the your technical definition of AI, then we can say that AI is nothing, it is the science and engineering of making intelligent machines, or you can say intelligent computer programs, okay. So we are making the intelligent programs, okay, the programs that are working intelligently, okay. And how the programs are working intelligently? They are working intelligently with some sort of knowledge, with some sort of information that we are giving to the your to the system, to the machine, right? And this information that we are giving is nothing, it is data science, it is basically your data that we are providing to the machine, okay. Unstructured form of facts and figures is data. When we are structuring them, then it becomes information, and when we are concluding something from it, then it becomes knowledge, right? So we have provided unstructured form of data, okay, to the machine, okay, fine. Then the machine will clean it, there are some cleaning algorithms are there, okay, and once it is cleaned, then the knowledge is being extracted through these AI algorithms, right? And once that is done, then we can get the output, at what is the final output in terms of different parameters, okay, numerical or statistical parameters, right? So this is your AI, okay. Now this AI field has was first coined, this term AI was first coined in the year 1956, right, in the at the Dartmouth conference, where the mathematician your John McCarthy, he organized a conference, and there he discussed about this term artificial intelligence, okay. And from there this term was first evolved, right? That this is the person John McCarthy who basically first coined the term in the conference. These are two basic scientists or the mathematicians, those who are well known, or the researchers you can say, who are well known for this field AI. Alan Turing is a scientist who basically conducted a Turing test, and from he in the 1950 he concluded this term. He come up with this term AI, right? He basically, what he did, he basically conducted a test. Okay, that test is known as the Turing test. In that test, there were three people who are sitting in different rooms, right? And all these three people are not connected physically; they are connected through some sort of LAN, right? Now C's questionnaire and A and B are the responder, right? C is continuously asking the questions to A and B, and in half of the time, C was not able to recognize whether the answers are coming from a human or from a computer, right? So when the answer, C was not able to recognize in 50% of the time that who is human, who is computer, okay, and he didn't recognize. So it means that the computer is giving the answers in the same way as a human is giving, right? So with this test, he wrote an article with machine intelligence, right? And he concluded, the Turing concluded that machine can think in the same way as a human is thinking, right? So this test is known as Turing test, and these were the two researchers, mathematicians, scientists who are well known for this, for evolving this term artificial intelligence in a society, right? Uh, So this was done in 1950, and we are living in which year? 2021, right? So around it is a gap of 70 years. Okay, so from that point 1950 to 2021, there has lot of research that has been done in this field, which is starting with the Turing test, to your Turing test, to the conference that was organized by your John McCarthy in 1956, to your Lisp machines. Okay, Lisp is a is a language that was first used to program your AI algorithms, right? Later, your chess game was also built using artificial intelligence. Okay, then your IBM Watson defeated the Ken Jennings in the Jeopardy show. Okay, so IBM Watson is again a program who has defeated the world best champion in the Jeopardy show, right? Jeopardy show is nothing. It is a it is your competition. Okay, for just like KBC, right? Later, your Siri app was developed. Okay, Google Assistant app was developed, and Facebook has used deep learning algorithms for recognizing the face of the human, right? Okay, later on, AlphaGo game was developed using AI. Okay, which has defeated the best chess playing game. Okay, that has been developed earlier, right? And now we are living in 2021, and we can think of that in near future that your self-driving cars will be there on in the roads. Okay, the driverless cars will be there on the roads of our country, right? Okay, so because you can see day by day the cities are becoming digital. Okay, smart cities. Okay, all the cities are connected with your cameras, right? And your sensors. Okay, different sort of sensors are there. So with this we are having a flood of data, and with this flood of data we can imagine that the things that were not possible before, those things are possible today, right? So and along with the advancement in the technology. So this is what I feel, that the combination of electronics and computer science, they are basically driving the society. Okay, until unless we don't have any high end equipment in the sense of your devices, or okay, we don't have sensors devices, until then we can't work with data science, right? So this is these two fields, electronics as well as computer science, they are driving the society. They are doing the things that are making the things possible, right? And all of you know about industrial evolution 4.0. Okay, in industrial evolution 4.0, we basically what is this? It is basically the implementation of AI, ML, blockchain, okay, data analytics, okay, IoT in industries. Okay, so every industry, data, mechanical, civil, electrical, electronics, they are driven by these innovative fields, right? So that's why this is the main reason why students are switching to computer science, right? Fine. So this is about the AI, right? Now, with the arrival, as this already I've discussed, with the arrival of efficient computers, algorithms, okay, as well as the research that has been done by the dedicated researchers in this area, the things are becoming possible. Means today we can think of that what the human is thinking, we can imitate the human thoughts. Okay, with the help of some sensors we can imitate what the human is thinking, right? Okay, with the sensors as well as the machine learning algorithms. Okay, we can take the EEG, electroencephalograph signals, and from those signals we can extract the information, and we can use these algorithms to find out what the human is thinking, right? We can understand the speech. You all know about NLP, natural language processing. Okay, we can do countless jobs. Okay, so this is the reason this is the reason why this field is widely used in the society these days, right? And all of you know about this robot, that is Sophia robot, right? Sophia is a humanoid robot that was developed by the Hong Kong based company Humanoid Hanson Robotics, and it was activated in the year 2016 in United States, Texas, right? And later it Sophia became the citizen of Saudi Arabia, right? This Sophia basically is using this AI technology. It is using computer vision, right, to find out who is the opponent. Okay, fine. Means image processing, with image processing and machine learning, it is finding out the person who is standing in front of the Sophia, right? With NLP, it is understanding the speech, what the human is saying in different languages, right? And this is all the it is the combined effort of computer science engineer and your electronics engineer and a design engineer who has built this robot, right? So this is the Sophia robot, which is again a innovation in our society. Next is Google Assistant. All of you know about Google Assistant Siri app, right? These are the apps that are navigating us to our destinations, right? And these are again AI based. Okay. Then Google Duplex. This is, I think, some of you have heard of this term, Google Duplex. The Google Duplex is again your AI based software, right? It is basically used these days in United States, New Zealand, Australia, Canada, and UK. This software basically works on this AI, and it basically used to book appointments or reservations for a person. Okay, so suppose you want to book a reservation for you around 7 p.m. to a doctor. Okay, so automatically the call will be made to a doctor, right, to the receptionist or the doctor, you can say, and it will understand what the receptionist is trying to say, and accordingly it will respond to the receptionist, right? So it is basically again a virtual assistant application for a human, right? And it is doing number of operations for the human, means booking appointments and reservations, right? Okay. Now Alpha Zero, I already discussed. I have discussed that this is a game. Alpha Zero is a game playing AI created by Google sibling DeepMind, and it has beaten the world's best chess playing computer program. And it has been taught in just 24 hours, right? It is basically based on reinforcement learning. Okay, learning from the environment, right? For what is reinforcement learning? Suppose we put, until unless we don't put our hand in the fire, we will not know that whether our hand will burn or not, right? So this is learning from rewards and punishments. That is your reinforcement learning, right? So this game has been has was just learned how to win the game in just 24 hours, right? So this is again unique application of AI. Coming to next application is your Daffodil software. This I think is a company in Gurgaon. This company has built a very good application, that is money application, right? So this money application was launched by Shakti Kantadas in your January 1st, 2020 in India. Actually, what happens that a survey was conducted in India, right? And in the survey, it was found that around 20% see or can't hear. Okay, they are visually impaired. Okay, visually impaired. Okay, so for them it is difficult to recognize the currency notes, right? So what they have done, that they have built this application. Okay, that is money application, and in this application they have created a data set of different currency notes. Okay, Indian currency notes. Okay, different of different value, right? Okay, and this data set they have created means the data set, the currency notes are placed in different angles, right? As well as in different sunlight. Okay, and accordingly a data set is created, and with this data set they have trained the algorithm. So whenever you install this app and whenever you put a currency note on top of your phone, right, so automatically you will recognize it, a particular vibration comes to you, that this currency note is of how much value, 10 rupee note, 100 rupee note, 200 rupee note, okay, or 500 or your 2000 rupee note, right? So this is the application that was a unique application, and it is helpful for the visually impaired people of a society, right? So this is again based on your machine learning and deep learning. Okay. Now, this is very interesting field in which I am working, right? I'm working. I have published quite number of research papers in this field, and that is swarm intelligence, right? Swarm intelligence is you can say very innovative field or very interesting field, right? Why innovative? Because here you can develop your own algorithms also, right? Day by day the people are developing their algorithms, fine. So this swarm intelligence is basically the collective behavior of decentralized self-organized system, natural artificial. So what is swarm is basically collective behavior of number of agents can be ants, birds, fish. Okay, so these agents, the collective behavior, okay, with this collective behavior a particular task has to be solved. Okay, what is that task? That task is optimization task. Suppose we are having any nonlinear function with us which is of very high dimension, right? And it is having suppose large number of variables, right? So in our school days what we do, how we optimize the function. if we remember our class 10 days, right? There what we do, we basically take a derivative of the function. Thereafter we take the double derivative of that function, and we basically see whether the result is greater than 0, less than 0, and we say that we got maxima or minima, right? So this is what we do in our school days. But if you see, if we are having the same function, but now the function is of n dimension, right? Okay, it is having n dimension and it is having nth order, right? Means x to the power 100 plus y to the power 50 plus z to the power 20 plus b to the power 10 plus 100. Suppose we have to optimize this function, then it will be very difficult for us to optimize this function numerically, okay, or mathematically, or using the conventional approach, right? Now if we optimize this function using these swarm intelligence algorithms, right, for example particle swarm or ant colony, then it would be easy for us to optimize these functions using these algorithms, right? And these algorithms are nothing, these are the man-made algorithms. This is AI, man-made, right? So these algorithms are basically built after inspiring from different things that are happening in our society. Means how the birds are moving, with that particle swarm optimization is made. How the ants are moving, okay, the ants are moving in a straight line, with that ant colony optimization is made. The your gray wolves are moving in a they are hunting their prey by encircling the prey. With that your gray wolf optimization is made, right? So these algorithms are basically are only the only thing that has to be kept in mind is how the animals are behaving, right? And if they are behaving collectively to hunt their prey, right? So with that algorithm can be made, right? So in last 20 years or 2 decades, number of researchers, they are day by day they are developing the algorithms, and they are solving different set of complex engineering problems, right? Because in engineering, you know that problems are mechanical engineering, electrical engineering problems are very complex, right? So it can't be solved using simple optimization techniques, mathematical analytical approaches. So there these algorithms finds wide application, right? I have also developed new algorithms, right? Not new, hybrid and modified algorithms, right? So as to improve the results, right? So this is a very good area of research where you can do research, where you can publish research articles, right? And what is the main reason that these algorithms have gained success? The main reason is that they are very simple. Okay, how birds are moving, based on that mathematically we frame the equations, and with that equations we can find out the result, right? So these are very simple to understand, they are flexible, they can be applied to any sort of problem. Don't have any derivative mechanism, right? Okay, we don't have to take derivative, and they avoid local optimas, right? Means suppose we are having a function in which we are having local optimas as well as global optima. So what is our aim? The aim is to find the global optima. So with these algorithms we can find the global optimas, right? So this is the main reason of success of these algorithms, right? Swarm intelligence algorithm or evolutionary algorithms, that is other category. So all these algorithms, evolutionary, swarm based, physics based, or humanoid based, teaching learning based algorithm, all comes under a single algorithm, that is meta heuristic algorithm. Meta means high level, heuristic means search. High level search algorithms are your algorithms which are used to find the solution to a problem, any optimization problem, right? So coming back to the data science, right? This is my favorite field. That's why I always discuss it in my lecture, right? So coming to AI, right? So as I was telling you that machine learning, deep learning, these algorithms are basically a subset of your AI, and these are used to understand the handwriting. They are used to understand the speech. Okay, they are used to build a robot. Okay, which can act, which can respond in a certain way, right? They are used to build your self-driving cars. They are used to play chess. They are used to play different games against opponent. We are having some game playing algorithms are also there, min max algorithm, alpha beta pruning algorithm. With those algorithms we can play the game, right? Between two players, right? So these are your different domains of artificial intelligence, which includes swarm intelligence, meta-heuristic approaches, machine learning, deep learning, right? Which includes computer vision, machine vision, right? Which includes your expert system, okay, which includes your soft computing techniques, okay, which includes heuristic approaches, which includes your game playing techniques, okay. So these all are the sub domains of AI. So what I can say here at this point is that AI is nothing, it is an interdisciplinary or multidisciplinary area having numerous diverse fields, subfields, and each one of these fields is an area of research in itself. Okay, suppose I am working in NLP, so it is also an research area, right? I am working on your soft computing techniques, that is your swarm intelligence algorithms, they are again in research area. If I am working on deep learning algorithms, they are again a research area. So every subfield of AI is a research area, right? Okay, and all these are basically used to extract knowledge, okay, to get solution to our problem, okay, nothing else, right? So this is the subdomains of AI. Okay, now let's talk of the languages that were used in AI, right? So in AI, different languages were used to build AI programs. Okay, initially list processing, then later on Prolog, that is programming logic, then your C language, and these days we are using Python, okay, for building the artificial intelligence programs, right? The reason being, Python is, all of you know that Python is an open source software. First reason. Second, that Python is having number of supporting libraries, okay, with which we can work on different set of problems, right? We are having TensorFlow, Keras for deep learning. We are having sklearn for machine learning, right? We are having your NumPy, Pandas, Matplotlib. Matplotlib is a library that is used for plotting the graphs. NumPy is used for numerical computation. For Pandas is used for data visualization, data processing, right? Okay, so all these libraries are available with us. We are having the tools with us. Okay, we can use these tools for different applications, right? Second reason, first is I told you that it is open source. Second is number of supporting libraries are present, and third reason, the reason I like most, right, is basically we can also work. It is not system dependent, right? Python. Okay, you can work on the system as well as you can work on the cloud. Okay, for example, if you are working on the system, you can download Anaconda. You can work on Spider, Jupyter, okay, for writing the programs, okay. And if you are not having any source of software with you, right? You don't have Anaconda software, right? You don't have Spider, Jupyter, your Windows where you can write, Editor Windows where you can write the program. There you can use this Google Colab, right? Google Colab is is a platform where you can write the programs on the cloud. Okay, so this Google Colab is basically, as the name suggests, only the thing you require is first is you require a system and you require a Gmail account. If you're having a system and a Gmail account, you can work on any system. Okay, only you have to open the Google Colab using the Gmail ID, right? Once you open the Google Colab, you can write the programs. You can work on different set of problems for your in Python, right? So this Google Colab is built by Google. That's why it is Google Colab. So similarly with Microsoft, as we are working today, I'm taking my lecture on Microsoft team, right? So we in Microsoft is also having a cloud, that is Microsoft Azure, okay, where you can write your programs, right? Similarly, AWS is also having a cloud where you can write the program, right? So different sources, different companies have created their cloud where you can implement your programs on the cloud, right? So this Google Colab is free, okay, it is free version, right? So it is widely being used, okay, because some applications of Azure are paid, some are free, so it's better to work on your Colab, right? So this is the reason why the Python language is widely being used in the industry as well as in the academics. This is the main reason, right? The three main reason. Your open source, okay, there's no you don't have to pay anything for the software. It is having a number of supporting libraries, and third reason, you can work on the system as well as you can work on the cloud, right? So these are the three reasons that this language has achieved quite wide your acceptance from the society, right? So this was your languages. Now coming, I will be going quickly through the applications because I have to cover quite a large content. Applications of AI is in home automation. You know that now I'm talking of, I have given you an introduction of to AI. Okay, what is AI is all about. Now I have discussed some applications. So some I will be discussing now, which are basically you see in our day-to-day life, right? as you all know that now the homes are becoming automated, right? So all the things are connected digitally, right? So you can suppose you are entering your home, automatically a door will open, okay, automatically a geyser will open, right, automatically the things will happen, right? So if you're having sensors and actuators, sensors are which are taking the information from the surrounding, sensors are basically, actuators are basically which are doing some action, right? And between sensor and actuator we are having these intelligent algorithms. So suppose sensor kya ho gaya aapka, if I take if you're entering the home, then sensor is your camera. Camera will recognize your face, right? So once the face has been recognized, camera will not recognize, camera will take the snapshot, it will take the data. At the back end you are having the machine learning algorithm, and that machine learning algorithm is basically trained, okay, that is, this machine learning is already trained. It is basically there in any microcontroller, RPi microcontroller you can take, okay, Raspberry Pi. And with that microcontroller, the training is done already. The test data, the random image at that moment of time will be taken of the owner of the house, okay. That image will be given to the controller. Controller is having this intelligent algorithm. There the decision will be taken, and that decision is given to actuator. Actuator will turn on or turn off the door, okay. So actuator is nothing, it is a motor, okay, it is making a things on or off, right? So this is the how the thing the home can be automated, okay, with the help of this algorithms as well as the electronic component, sensors, actuators, right? So this is home automation, right? Next application is basically precision agriculture. Now all of you know that day by day the land the population is increasing, right? Land is limited only, right? We have to survive in this country, okay, we have to survive, we have to get food from the from agriculture lands, right? But what you are seeing in your around your surrounding, that agriculture land is decreasing day by day, right? And in future what your food scarcity can happen, right? So in order to secure the food requirement of next generation, our government is planning to have precision farming, right? In the precision farming, what happens that all these your electronic components as well as your AI algorithms, they will be used in conjunction, okay, and they will be used in such a way to get the best output from a particular field, right? So for example, in the precision agriculture, crop will be sowed in crop will be sowed based on the you can say the based on the land, okay, what is in which area which crop can be grown, okay. So this will be decided by the machine learning algorithm, right? So your how to control the pest and weed, okay, because you all know that pest and weed basically are basically your they are uh, decreasing the growth of our plants, growth of our agriculture plants, right? So using drones, and if those drones are having cameras, right, and they are having intelligent algorithms, right? So they are the your pest control fluid can be you can say they can be assembled in the drones. Drones will be moving towards the agriculture land. Drones will be taking the picture in real time. They will be analyzing that whether this plant is having pest or weed, right? It is having pest or not, or it is having weed, it is a weed or not, right? And accordingly it will spray the your different spray your you can say uh, mm, fertilizers, right? Pesticides, okay, so that the your pest and weed can be controlled, right? Or intelligent harvesting can be done, right, using robots. These days a number of your you can say in a society where humans are basically the are used for harvesting, right? If we are using robots, then they can save the time, okay. As you can see on the screen, that AI enabled robots are being widely deployed in tomato farms in Japan, and they have reduced the labor by 20%. They can be used in drip irrigation also, right? So these are the areas or precision agriculture, okay, which can maximize the growth from our agriculture land, right? Next, AI can be used in self-driving cars, okay. In the driverless cars, if we have some sensors and actuators as well as the intelligent algorithms as well as the controllers, then these cars can automatically navigate without the driver from source to destination, right? Then going talking of your manufacturing industry, right? So if the manufacturing industry will be using robots, so the robots can be used to do laborious tasks. Robots can be used to identify the faults in the devices that are being built, right? So the productivity from the industry will be increased. Okay, once these algorithms, these AI enabled robots are used in the industry, or the algorithms are used in the industry, right? Now in the education, we don't know in near future that we will be finding teachers they are which are robots, right? Because robots, as you know, that they don't have emotions, they only have the intelligence, right? So they can better teach the students, or they can better build the curriculum of different disciplines, right? So this is also one of the area. Next is healthcare, right? So doctor in medical fraternity has already been using these machine learning, deep learning algorithms for identifying the disease. Okay, these algorithms, the data set of different chest x-ray images, or your chest x-ray images, or images of different parts of the body is being collected, and a data set is created, and with that it can be identified that a person is suffering from which disease, right? These days, in last year, when COVID came, then in the initial stages, when there was scarcity of the kits, okay, then these X-ray, using X-ray images or the CT scan images, the COVID, it was identified that the person is suffering from COVID or not, right? This is not giving the 100% right result, but with the scarcity of the your kids, they this particular, you can say, this option was chosen, right? Because I think these rays are not good for the health of a person, right? But with initially your China has also used these chest X-ray image and the CT scan images to identify the COVID patient, right? Okay, so this is this your AI is widely being used in the healthcare industry, right? So in the finance, it is can be used to identify the trends of the markets, okay, or to identify defaulters in the defaulters while issuing a loan, right? In now coming to my field, that AI is transforming the electronics industry, right? In the near future, you will find that Samsung and your Samsung has already announced that they will be using the AI capabilities in every device they will be manufacturing by 2020, right? Intel, Google, Apple, all these giant companies, they are basically developing the processors which are AI enabled, right? And the IBM has also revealed that the 40% of the electronic companies launching or modifying the new business, okay, models in the next 2 to 3 years, okay, and they will be AI, or they will be AI enabled, right? Okay, in the RF industry also, means in the radio frequency industry, yeah, I'm working on smart antennas, being from electronics domain, right? So I'm also working on estimating the direction of the user of beamforming, right? So there again, you can implement these machine learning, deep learning algorithms. So what I feel that the application of AI is endless. Okay, either it can be used in your finance, in banking, in your electronics industry, in as I told you, industry 4.0. Okay, in every industry, core industry, AI will be used, right? In your education industry, healthcare industry, manufacturing industry, everywhere. This field is transforming the society, right? So these are the main applications of AI in a day-to-day life. So till now I have covered 2 points, that is basics of AI, and next the applications of AI in a day-to-day life. Now I will be coming to the your subfields of AI, and more specifically I will be talking about your machine learning and deep learning, right? That is because this your FDPs is basically dealing with your data science with Python, right? So coming to your data science only, right? So your AI is a bigger field, right? Bigger umbrella. Under this umbrella, we are having these two fields, right? Machine learning, deep learning, right? Okay. So machine learning, if I say, AI is bigger umbrella, which basically with which we can program, or it is a program, man-made intelligence that we are giving to a machine, okay, with which machine can sense, reason, act, and adapt, right? And this is AI, right? Machine learning are the algorithms whose performance improve as they are exposed to more data over the time, right? So when we are providing more data to the machines, they will be exposed to more data, their accuracy will be increased, okay, and they will be more accurately giving the output, right? So machine learning is the subfield of computer science that gives computer the ability to learn without being explicitly programmed. Okay. What in a traditional programming, what you do? Okay, you are from computer science. You are writing the program. You're giving the input. You're getting the output, right? If I write the program for Fibonacci series, okay, then I will be writing the logic, okay, and with that logic, I will be creating a Fibonacci series, right? This is a traditional programming. Input plus output, input plus program giving you the output. Machine learning, deep learning case is different. Here we are having the output and input, and accordingly a relationship between input and output will be generated at the back end of the algorithm. Okay, algorithm will learn how the input is related to the output, and once the algorithm has learned that nonlinear relationship, it will give you the output for the unseen input. That is generalization, right? So this is machine learning. Means learning, it is different from the traditional programming. Okay, this is a field of computer science, statistics, mathematics, whichever you say. Okay, which with which the computers are building the ability with which they are intelligently taking the decisions, intelligently giving you the conclusion. Okay, I told you the starting. Your AI is data science is basically the field where the stakeholders are coming up to a conclusion with a set of data, right? So how that the stakeholders are coming to a conclusion with that data, they're coming to a conclusion with these MLDL algorithms, right? These algorithms are basically building the nonlinear relationship between the input output with that data set. If the data set is labeled, they are using supervised algorithms. If the data set is not labeled, they are using unsupervised algorithms, right? If the data set is very complex, okay, if the complexity of data set is very high, right, then we can go with or the dimensionality of the data is very high, then we can go with deep learning algorithms. So we are having quite large bunch of algorithms with us, right? We can play with these algorithms if we know how to play, right? So it is very easy field, machine learning, deep learning. Okay, today I am giving a lecture being from electronics domain, so I feel that it is not a tough field, right? We only require the logical knowledge, right? If you're having a logical thinking, we can work on these algorithms, right? So machine learning is basically as I told, that it is with more amount of data, the performance will improve, right? So these are machine learning algorithms, right? So sub part of machine learning, you can say deep learning, right? So whenever the network, okay, the learning is inspired from the neural network, the network that we are having in our brain, the neural network of human, right? If you are using neural networks to predict the output, there we can say that these are your deep learning algorithms. Okay, so deep learning is a subset of machine learning in which multi-layer neural network learn from vast amount of data, right? So these are these all three domains are interrelated: AI, ML, and DL, right? Okay. Now, and there was a scientist or Nobel Prize winner, Herbert Simon, who says that learning is any process by which a system improves its performance from the experience, right? With more experience, human will improve the performance, right? If you're having more good experience in working in AI, ML, DL algorithms, you will be solving the problem. If you're having a lack experience, then you will require some time to solve the problem, right? So as you know, practice makes man perfect, right? So with more experience, with more data set, the algorithm performance will improve, right? So machine learning is concerned with computer programs that automatically improve their performance through the experiences, right? So this is how we can correlate the human way of learning or the learning how the machine is taking place. They are directly proportional to each other, right? So this is the machine learning, the subfield of computer science, with which the computer having the ability to learn without being explicitly programmed, right? Now, for example, if we are having a problem statement, right, we are having different leaves with us, right? Different species of flowers, with us, and we are characterizing the flowers with respect to sepal length, sepal width, petal length, petal width. Okay, and we are having, based on these, we're having the species, right? So if you're having this problem statement, right, so we can find out that which species is this flower is, right? So okay, so this is a problem. Okay, so with this data set, we made the machine learn, right? Machine is learning with this data, right? And once machine has learned, okay, then for a random sepal length, sepal width, petal length, petal width, we can find out which flower is this, right? So this is nothing. This is a particular problem in which we have trained a machine, and when the machine is trained, then machine will generalize, okay, give you the output for the random input. This is machine learning or any learning, right? Learning machine, remove machine or deep, right? It is learning, right? We are learning the things, okay, and once we have learned the things, then we are giving you the output for any input, right? So this is your machine learning and deep learning. The basic difference between these two I will discuss later, right? So till now only understand that we are learning the things from the data and we are exploring the thing, we are exploring the data, okay, we are extracting knowledge from that data and we are basically giving the result either in the form of predictions or in the form of classifications, right? Fine. So okay, I'm just taking a break. 1 second. Okay, so how do machine learn, right? And this all we have learned till now, that how the machine is learning. Machine is learning with some set of data. Okay, abstraction means deriving a conceptual map based on the input data. It is abstracting the knowledge from that data, right? So once the knowledge has been extracted from the data set, the a random predictions or classifications can be done. Okay, so the abstracted representation is generalized to form a framework for making intelligent decisions. So we are having a input data, we are having a data, we are abstracting the knowledge from the data, and we are giving, we are with that knowledge, we are coming up with some conclusions, right? Okay, so with this, the machine is learning new things, right? So the steps that are involved in machine learning is gathering the data, okay, cleaning the data, because I told you data is not clean always, right? It is having noise, it is having some outliers. Okay, we have to clean the data. Once the data is clean, then we have to build models. We have to select the algorithm that we will be using for a problem, because there are number of algorithms are there. I will be discussing next, right? Number of regression algorithms, classification algorithms are there, which can be used for the problem, right? Fine. So we have to decide which algorithm we will be using. Then we will be training the data with that. We are training the algorithm with the data, and once the algorithm has been trained, right, then we can get the output for any input, right? So this is the steps that are involved in machine learning. Okay. Next is, what is the present need of studies?
Sorry, sir.
Yes.
There is a question from the participants. He asking that are you going to discuss the Python coding part of?
Right. I will be discussing in the last, right? Yes. Okay. So there is a present. Why? What is the present need of study, right? What is the present need of study of this MLDL, right? This is because the flood of data that is available to us, because of the high compute as well as from the academics, right? So with this flood of data, with this high-end computational devices, as well as with the support from academics and the industry, this field is has experienced such growth, right? So this is the present need of study, and this is the reason why it is being used, right? Now, when to use machine learning, right? So this is also a very good question, that when we will be using machine learning. Okay, machine learning will be used when human expertise don't exist, right? Suppose we are not able to recognize something. Okay, we are having some image in front of us, and we are not able to recognize it. What is that image? Okay, what are the numbers that are present in that image, or what are the images, what exactly that image is, right? So there we can use machine learning. We can use machine learning when we are not able to recognize a speech. Okay, we can use machine learning to find solutions that are changing over the time. We can use machine learning to identify whether the mails are spam or non-spam. Okay, so the things where the laborious task is done, right? For example, identifying the mails, okay, or where the human can't judge, okay, what is the output, right? There we can use the machine learning algorithms, right? So this is the classic example. Okay, the example of a task that requires machine learning, right? So it is very hard to say what makes a two, right? So if we are training a machine with this data set, then for a random input we can find out where we are having this, where which is true or which is not true, right? So here we can use machine learning, right, for identifying the face. Okay, if you're having a training data set of images, then we can find out that which we can identify a person with this machine learning algorithms, right? Now the activities that are involved in machine learning, right, this is also very important. that we are having a data set. Okay, we have to prepare our model, right? Okay, the algorithm that we will be using, right? Then the learning will take place. Okay, once the model has learned, okay, then we will be evaluating the performance of our model. And once we have evaluated the performance of our model on different parameters, then we will be improving the performance of our model, okay, by varying the constant parameters, or by varying different aspects that are involved in machine learning, right? For example, if we are dividing data into different sets, training, testing, if we can use holdout approach or k-fold cross validation approach or bootstrap sampling approach. So different things are there, different aspects are there which we can, with which we can improve the performance of our model, right? So this is the steps that are involved. First we have to prepare a model, then the learning will take place, then the performance will be evaluated, and then the fine tuning will be done, right? So these are the critical steps involved in machine learning. Fine. Now this is very important question. Whenever you will be working on machine learning, you will be you have to find out that which algorithm to use, right? So this is a very critical thing that that nobody knows, right? Or the people who are having good experience in this field, later they can say that this algorithm can be used or that can be used, right? So there is a theorem that says no free lunch theorem, right? So this theorem says that there is no algorithm that can give us the best result for every set of problem. Okay, so we have to check whether, based on the algorithm, we will be checking that this algorithm is giving us the best result or that algorithm is giving us the best result, because there are a number of algorithms. Okay, and we can't say at random that this algorithm will be giving us a good result. So what is the theorem? No free lunch theorem. This is applicable to MLDL as well as it is applicable to swarm intelligence. Okay, we can't say that this particular optimization algorithm is the best algorithm, right? So it is a very tricky thing to select an algorithm for a particular set of problem, right? Okay. So basically there are two sets of problems, right, which are there in machine learning or deep learning. That is predictive problem, okay, or your predictive problem, or second is your one second descriptive models, right? Predictive models and descriptive models, right? So whenever we are doing prediction can be whether the cricket match will be won or lose by a country, right? Whether a transaction is fraud or not, right? So this is an example where the output is a categorical value, yes or no, okay, or win or lose, right? So this is a particular class of problem, that is a classification problem that comes under supervised learning, right? Okay, so this is a predictive models, right? So predictive model may also be used to predict numerical value. Whenever we want to predict what will the temperature of Masuri on a certain day, then we can use these regression algorithms, right? So regression algorithms are used for predicting the numerical value, right? So what is the prediction of revenge growth in the succeeding year, or what is the prediction of rainfall in a certain city on a certain day? That is we are predicting the numerical value, right? So we can predict the categorical value, we can also predict the numerical value, right? Okay. So these were the two set of problems where we are having a there the models are supervised models, right? Means we are having a data set in which we are having input as well as the output. Input be or output be, right? Now, if we are having a data set which is in a form that we only have the inputs, okay. So model for this we are using unsupervised machine learning algorithms, okay. So for models for unsupervised learning or descriptive models are used to describe a data set or gain insight from a data set. So there is no target or single feature of interest in case of unsupervised learning. Based on the similarity of the data, based on the features of the data, we are basically extracting the common features in the data, and accordingly we are basically working on unsupervised set of data, or it is unsupervised learning without a teacher, right? And the algorithms that comes under it are clustering algorithms, right? For example, if a movie release, okay, in the country, okay, and it has to be identified that in which part of the country more promotion has to be done, right? So how it can be done? Okay, we can't take a survey from the people that whether the movie should be more publicized in a certain city or not publicized in a certain city. This has to be done through randomly, right? This is an unsupervised problem, right? Where we are having where we have to decide by extracting features from the country, right? What features? For example, a Bollywood movie release. Okay, so in the south, the promotion will be less. In the north, promotion will be more. Okay, in the northeast, promotion will be less. In the northwest, promotion will be more. Right. So based on the liking of the people, based on the taste of the people. The movie promotion will be done in certain part of country more and less in the other part of the country, right? So this is basically a problem that comes under unsupervised learning, where we are doing segment, we are building clusters based on the common features of the data. Okay, so examples are customer grouping or segmentation based on social demographic factors, grouping of music based on different aspects, grouping of commodities in an inventory, right? So here, based on the features, we are making a groups or the clusters, right? Now, this also is a very important thing that you need to understand while you are working in any ML or DL techniques, right? That are three techniques are there, right? To divide the data into training and testing. Now, what is training and what is testing? Suppose we are having a data set with us, right? So, and we in that data set we have to we have to find the performance of any particular machine learning algorithm, right? Now we are dividing the data set into training and testing, right? So training means, suppose in the first technique is holdout method. In the holdout method, we are dividing the data into training and testing 70-30%. 70% of data is used for training, rest 30% data is used for testing. Okay, or 70 to 80 for training and 20 to 30 for testing, right? So here, once the model is trained, then test data will be used to check the performance of the model. Okay, what is the performance of the model, right? And this is done randomly, right? This is the holdout method. Now next is k-fold cross-validation method, in which we are dividing the data into training and testing in different in different folds. Okay, means suppose we are having 100 samples. So first 10 samples used for test, rest 90 for training. Next 10 is used for test. Then and at last the average of all the outcomes is done so as to find out the performance of a model. So I told you now we are optimizing the, you can say, the performance of our model. We are tuning it, right? How we are tuning it? We are tuning it in this way only, right? By using different approaches, right? So you, in the k-fold cross validation, whenever we are having a small data set, in that case what we do, we basically divide the data set into training and testing in different iterations, and we take the average of all the iterations, right? This is a k-fold cross validation method, right? Next is your bootstrap sampling, right? In the bootstrap sampling, what we do, we basically have a flood of data with us, right? So at random the data is picked for training and testing. From whole set of data we are randomly picking the data for training and testing, right? And at last we are taking the average of all the iterations. What is the difference between this and k-fold cross validation? In k-fold cross validation, the data will not repeat. Okay, data will not repeat. Here you can see first 10 data set, for example, first 5 data set is used for test, rest training. Next 5 for test, rest for training. Next 5 for test, next for training. Last 5 for test, rest for training, right? So here the data will not repeat. But in the case of bootstrap sampling, it is basically it is random sampling with replacement, right? So here we are having a data set. Right. So in this, we are having a data set with us, and we are basically randomly picking a data from that flood of data, right? And we are doing the training and testing, and we are taking the average in the last, right? So this is the basic difference between bootstrap and the k-fold cross validation. So you can use any of the three approaches: holdout method for dividing data into training and testing, or k-fold cross validation method, or you can say bootstrap sampling. Okay, and you can analyze the performance of all the three methods so as to get the best performance of your machine learning or deep learning algorithm, right? Okay, so this was related to data, right? The how the data is being divided, right? Now you should also know what are the different machine learning algorithms, right? So now I will be discussing with you different algorithms, okay, that you can use at quickly, right? And at last I will be discussing when to use machine learning, when to use deep learning, and what are deep learning algorithms, right? So this I will be discussing next, right? So machine learning, as I told you, machine learning algorithms are classified into three broad categories. That is supervised learning, learning with a teacher. Whenever we are having a labeled data set, we are working on supervised machine learning algorithms. Whenever we are having data set that is unlabeled, right, there we are using unsupervised machine learning algorithms, right? And whenever we are working on the problems in which we are basically learning from the environment, right, with rewards and punishment, there we are using the reinforcement learning algorithms, right? So these are the three categories: supervised, unsupervised, and the reinforcement learning, right? Fine. So now first learning is that is supervised, right? Supervised learning is learning with a teacher. Whenever we are learning with a teacher, we are working with a labeled data set. Okay, and we are doing some predictions or classifications, right? Predictions means we are either predicting a numerical value or we are predicting any category value, right? So there we are using the supervised machine learning algorithms, right? So supervised machine learning is as good as the data used to train it. If the trained data is of poor quality, the prediction will also be far from being precise, right? So we should have good data set with us. If we are not having good data set with us, we should use some algorithm. We should use some cleaning algorithms, data cleaning, data pre-processing before we are using these algorithms. Okay, so the your clean how clean the data is. Okay, what is the purity of the data? This will play a major role in the performance of our algorithm, right? अगर data clean नहीं है, then we have to clean it before, right? So the main thing that comes in machine learning is basically machine learning algorithm is a one-step algorithm. Okay, only you need to, if you are using sklearn library, you need to call the algorithm. You can call any regression algorithm, any classification algorithm. Okay, only 3 to 4 line code. Okay, before that you have to call the libraries. After you have called the libraries, you have to call the data. Once you have called the data, you have to clean the data. Once you have cleaned the data, then you have to call the model. Okay, once you have called the model, then you have to estimate the performance of a model, and and your work is done, right? So the how the work is done in Python programming language, it is not a very tedious task. It is very easy task. Okay, but the thing that you have to keep in mind whenever you're solving any ML or DL problem is that your data should be good enough that it will give you the good results, right? So data pre-processing plays a very, very important role, okay, in your machine learning or deep learning. Okay, so a data scientist basically see the data and accordingly it take the decision that what approach should be taken so as to make the data clean. Okay, fine. Okay, so this is a supervised learning, means learning with a teacher or working with a labeled data set. Here in the diagram you can see we are having duck, not duck. Okay, and we are making it learn with the algorithm, and the predictive model basically tell you whether the new animal is duck or non-duck, right? So this is supervised learning with a label data set. So यहाँ label कैसे है data set? देखो आप जो in the diagram you can see that with respect to each animal you are having the name is written. It is duck or it is not duck. It is duck. It is not duck. Means it is a label data set. So label data set. Whenever we are having label data set, we are working with supervised machine learning algorithms, right? So supervised learning in ML is basically we are having an input raw data set with us. Okay, we are cleaning the data. Once data is clean, we are pre-processing the data through the algorithm, and there we are doing at last we are doing the predictions, right? So this is supervised learning. So we are having raw data, we are extracting features from the data, we are training the model. Okay, we are evaluating the performance of our model, and once the performance of our model is evaluated, then for any random new data, we are predicting it. What is the output, right? So steps involved in machine learning, if I say in terms of Python language, right? First is calling the libraries. Second step is basically your calling the data. Third step is pre-processing the data. Fourth step is calling the algorithm. Fifth step is your once you have called the algorithm, you are calling the parameters. Okay, which parameters you are choosing to evaluate its performance. At last, you are checking for any random input what is the output, right? So this is your supervised learning or any machine learning algorithms that you are implementing in any programming language, right? Okay, so whenever you are predicting a real values, these algorithms comes under regression. Okay, means you are finding out the best fit line with which you are finding out the output, right? Once for predicting the categorical value, you are basically you are using the classification algorithms, and for that you are basically making a separate line or you are dividing the two entities with certain set of hyperplane, right? That I will be discussing next. So only you need to understand is that in regression you are basically finding out the numerical value. In classification you are finding out the categorical value, okay, or you are predicting the categorical value. Categorical value matlab yes, no, okay, or good, bad, average. Numerical value is 1, 2, 3, 4, any value, any real value, right? Okay, so examples are regression is whenever we have to forecast anything? Okay, whenever we have to do predictions for the sales, whenever we have to do forecasting for weather. Okay, classification algorithms are, we have to find out whether the game will be won by India or not. Okay, or whether what is the, we have to recognize the handwriting, this handwriting is of Suresh or not, right? Or whenever we have to predict that this person is suffering from COVID or not from the chest X-ray images, right? Okay, so these are your classification problems. Okay, so these are the two set of main problems that comes under supervised learning, right? Okay, so in regression, we are basically predicting the numerical value, right? So regression is essentially finding a relationship or association between the dependent variable and the independent variable to find out the function for the association y equals to fx. So a non-linear relationship between input and output is being recognized by these regression algorithms, right? Okay. So algorithms that comes under regression are simple linear, multiple linear, polynomial, logistic, right? So in case of simple linear regression, we are having input, we are having outputs, right? And y here in this case is dependent variable, x is independent variable. So we are having only one independent variable in case of simple linear regression, and we are basically finding out the values of a and b. Y equals to mx plus c. M and c values are being found out. Once we know the value of a and b, then this regression line can be plotted. Okay, this regression line can be plotted, and for any random value of x, we can find out the value of y. Again, for any random value of x, we can find out the value of y, right? In case of simple linear regression, right? Okay, so there are two algorithms that can be used for finding out the values of a and b. Okay, first you can use the ordinary least square algorithm, where you can find out the difference between once I'm just taking a question with for this, right? Suppose we are having this data set x and y, right? X is the internal marks, y is the external marks that the student got in RKGIT, for example, right? Now these are the set of marks of different students. How many students we are having? We are having these students, right? Now what have to we have to do that based on the internal marks of any student, we have to find out what will be the external marks of that student, right? Suppose we are having a data set of 20 students, okay, and these 20 students are studying in RKGIT in computer science in second year, right? So we basically plot a relationship between internal and external marks, right? Now if I say give you a random student, okay, whose internal marks is this, and I want to know that what is the external marks of this student, I can find it using regression algorithm, right? So what I will be doing, I will be taking the mean of x, I will be taking the mean of y. Okay, I will be subtracting every entity with mean of x and mean of y, and I will be squaring it, xi minus x ka square. Okay, so this is the ordinary least square algorithm where we are calculating the mean of x and y. We are finding out its product. We are finding out the square of the summation of the product. We are finding the square of the x. Then we are getting the sum of the square difference, and then we are finding out the value of a and b using these relations. We are finding a sum square error, and b is basically the summation of xi minus x bar yi minus y bar upon xi minus x bar ka square, means covariance xi upon variance x. This with this we can find the value of b, and a is mean of y minus b into mean of x. With this we can find out the value of a. So once we find out the value of a and b, then what we can do, we can find out for any x what is a y. Kaise, how it can be done? B we have found out, a we have found out, right? Now this is the equation that we have found out. This is the equation that we have obtained using this ordinary least square algorithm, and for any x we can find out what is the y. Means for any internal marks we can find out what is the external marks of the student. So this is the ordinary least square algorithm which is the basic working of your simple linear regression algorithm, right? Now there is one more algorithm is there, that is gradient descent algorithm. In the gradient descent algorithm, what is happening, we are basically taking our random values of x and random values of the input parameters a and b, slope and the intercept, okay, and step by step, okay, in the iterative way we are finding out what is the optimized values of a and b. Gradient descent means we are minimizing the value of error in the negative direction of the gradient. Okay, we are minimizing the value of error in the negative direction of gradient. Okay, a and b, slope and the intercept are taken randomly initially, and then we are minimizing it with all the data set that we are having with us, and accordingly we are finding out the values of optimized values of A and B, okay, by moving in the negative direction of the gradient, right? Okay, so fine, this is the gradient descent where we are moving in the negative direction of the gradient, right? So this is a gradient descent algorithm, right? With this you can find out the optimized values of the slope and the intercept, right? Okay, so okay, so this is gradient descent. I will not discuss it more, right? Now, coming to multiple linear regression, whenever we are having multiple parameters, right, means multiple independent variables, right, not single, then the algorithm is basically your multiple linear regression algorithm, where we are having your inputs, where we are having number of independent variable. For example, the example that I will be discussing today on Python, that we are having fuel consumption. Fuel consumption is dependent on various inputs of a motorbike. Okay, fine. Now, if you are taking single parameter to find out what is the CO2 emission, right? Then it is single. Then this is basically your simple linear regression. When we have taking multiple parameters of input, right, for finding out what is the fuel consumption, then it is multiple linear regression. So, जहाँ पर independent variables are more than one, then that algorithm is multiple linear regression, right? Now suppose here you have seen that there's a linear relationship between input and output, right? When the input or output are related non-linearly, okay, then this algorithm is basically your polynomial regression algorithm, right? That is, you can see y equals to b0 plus b1 x1 plus b2 x1 square plus bn x1 n. So here the input output are related non-linearly, and this is an example of polynomial regression, right? Okay. Next is your, so this you can see in the graph that in the simple linear regression we are having a straight line, polynomial regression we are having a nonlinear curve, right? Now when we are having the output in the form of zeros and ones, okay, till now we have discussed that output can be continuous, right? Now whenever the output is in the form of zeros and ones, right, there we are using logistic regression. So we are having a basic idea. Whenever we are predicting numerical value, we will be going with the regression algorithm. Whenever we are predicting the output which is only 0 and 1, then we will be going with logistic regression. Okay, logistic regression also comes under classification, right? Because we are having only two outputs, yes or no, right? Or 0 or 1, right? So logistic regression is basically the regression algorithm in which the output is binary, 0 and 1. Okay, and the goal of the logistic regression is to predict the likelihood of y to be 1 or to be 1 given certain values of x, right? So जो कोई भी इनपुट वैल्यू, इनपुट जो है आपके वो है इंडिपेंडेंट, वो है कंटिन्यूस वैल्यूज. Input are continuous values, but output is 0 and 1 only. So for any input, random input, you have to find out what is the probability that output is 1 or output is 0. So that you are finding using the logistic regression algorithm, right? So here you can see. So we are basically using this logistic model to find out what is the output. Output is 1 or 0. Okay. So to predict whether an email is spam or non-spam, whether the tumor is malignant or benign. Okay. That you can find using the logistic regression, right? So whenever you see that whether when the inputs are continuous, output is binary, you can go with logistic regression, right? Now this is very important. Okay, that till now we have discussed some regression algorithms. So when which algorithm is good, which is bad, that is very important to judge, right? That we will be doing today in Python, right? That suppose we are having actual value, we are having predicted value, right? And we have to find out what is the performance of the model, right? Then we can measure the performance of our model using this errors. Okay, mean square error means the difference summation of the actual value minus predicted value divided by total number of values, mean absolute error, mean square error. अगर error का square ले लिया, right? If we are taking the square root of the square of all the errors, then root mean square error, right? Then relative square error, if you are finding the ratio of this absolute error upon the mean, subtracting the actual value, subtracting the actual values from the mean, right? This is the relative square error. Relative square error, if you are taking a ratio of mean square error upon the mean square error with respect to the mean, okay, that is your relative square error. And the difference between 1, if I subtract the relative square error with 1, okay, then it becomes r square, means coefficient of determination. It is very important, right? So jitna error kam hoga, coefficient relation determination utna zyada hoga, right? So the better the r square value, better is your better is your algorithm. Okay. So if your algorithm is giving good transfer value, then you have to go with that particular algorithm, right? So this is very important parameter to analyze the performance of any supervised regression algorithm, right? Okay. Now next is classification. Whenever you are basically predicting any categorical value, you are working with the classification algorithms, right? Okay, where means you have to find out whether this animal is cat or dog. Okay, this is your classification. You are finding out the category. Okay, not a numerical value, right? So it is a data mining task of predicting the value of a categorical value, target or class, right? For example, here you can see in the diagram we are having triangles and circles, right? So you are separating a line to classify that these are class A or class B symbols, right? So machine learning classification workflow, again we are doing the training and then we are doing the testing. In training we are basically having a data set with us. Only the difference is that here the output is in the form of some numerical, not in the form of some numerical value, but in the form of some categorical value, right? So that is the classification, right? So we are training the algorithm with this set of data, and once the algorithm is trained, right, then for any random input we can find out that what is the predicted categorical value at the output, right? So this is the workflow, right? So all the things are same, but only the difference is that data set is a categorical data set, right? So classification algorithms are basically, I told you that logistic regression also comes under classification. Its name is regression, but it comes under classification. Reason being that here we are basically predicting any two outputs. Okay, output can be category, 0 and 1, yes or no, right? So it comes under logistic. It comes under classification. Support vector machines, decision trees, KNN, your random forest. These all are the classification algorithms, right? So the steps that are involved in classification are that first we need to identify the problem. Okay, then we have to pre-process the data, then we have to define what is training, what is testing, then we have to select the algorithm, then once the algorithm is selected, then we have to train the algorithm, right, with that data set, and once the algorithm is trained, then we have to evaluate the performance of our algorithm, right? And this is the steps that are involved in classification, right? The algorithms that are in classification are there are many algorithms. I will be discussing some of them. The important ones, that is KNN. KNN stands for K nearest neighborhood, right? So this is a very lazy classifier. Reason being that here we are not doing any sort of training, right? What we are doing, suppose we are having a data set with us, right? Then with that data set, we are basically finding out the distance of that data set with the test data set, right? That's the equivalent distance, and based on the equivalent distance we are saying, suppose we are taking three neighbors, so based on the class of those three neighbors, we are saying that this test data set is of this category. Okay, so this is KNN. I'm explaining you with an example, right? Suppose this is a data set we are having with us, right? So this is a training and test data set. Training is we are having different names for the students whose aptitude, these are marks, aptitude, communication, right? And what is the output? That based on these aptitude and communication, they are, if both are good, if they are having good aptitude and good communication, they are leader. If they are having good communication, bad aptitude, they are speaker. If they are having bad communication, good aptitude, right, they are intel. So for random input, okay, these are the students. Okay, now for random input or random student Josh, we have to identify that this Josh will be in which class, speaker, intel or leader, right? So what I will be doing, I will be finding out the equivalent distance of this Josh with all the students, right? And these are the distance that you can see in the last column, and based on that I can take any random value of k. Okay, k can be 2, 3, 4. So अगर जो nearest दो होंगे, जो दो nearest value होंगी, based on that we are saying that this is speaker if k is value is 2, or intel or leader if we are saying k value is 3. So again based on those three values we are saying that this is intel, speaker or leader, right? So it is a very tricky algorithm. Why? Because the value of k is very difficult to determine, right? Value of k can be large. If you are taking large value of k, the result will be different. If you are taking small value of k, the result will be different, right? So what I personally do, or I personally tell the students in my class, that take different values of k, and for all the values of k, find out the result. in terms of R square, in terms of the parameters that we are choosing, right? That I will be discussing next. So based on that, we are identifying that which algorithm I will be using. I will be using what value of k I will be using, right? I will be using value of k 2, 3, 4, or 5, for example, right? So we can take different values of k, and based on that, you can find out which is the best one, right? So this is the KNN, k nearest neighborhood algorithm. Okay, this is the algorithm, right? Now, SVM is a very simple algorithm in which what we are doing, we are basically creating a hyperplane between the data set. What we are doing, we are plotting the data set. Okay, once we have plotted the data set, then if the data set is linearly separable, we are drawing a straight line or hyperplane to separate the data set. If the data set is not, linearly separable, then we are transferring the data set from lower dimension to a higher dimension, and we are drawing a hyperplane to separate the data set. So in this way, we are creating a n-dimensional hyperplane to separate the data set. Right here you can see. राइट दिस आर टू डायमेंशनल डेटा सेट यहाँ पे हमने स्ट्रेट लाइन ड्रॉ कर दी इसको सेपरेट कर दिया राइट एंड वी हैव डन क्लासिफिकेशन दिस इज क्लास ए और क्लास बी राइट in multi-dimensional data set we are drawing a hyperplane to separate the data set. Okay, these are data set that are linearly separable. अगर data set है जो linearly separable नहीं है right, so in that case we are taking data set to higher order dimension and we are separating it right. So this is your SVM, support vector machines, right? Why it is support vector machines? Because we are creating a straight lines, the support vectors, right? Which are basically used to create a hyperplane between the entities, right? So here these green and blue color is the support vectors which are basically used to make this positive and the negative hyperplane, and the difference between these hyperplanes is nothing, this is the margin, right? So if you're having small margin, the algorithm will be prone to error. If you're having larger margin, then the algorithm will not be prone to error, right? So this is the SVM support vector machines, right? Okay. Now we have four scenarios. In these four scenarios, we are basically drawing a hyperplane, and based on that, we can say that which is better, which is not better, right? So in scenario 1, we are having three hyperplane A, B, C. A is the best one. In scenario 2, again we are having three hyperplane. A is the best one. In scenario 3, your B is best. A is best one, right? Because with B we are having triangle on this side, right? In scenario 4, it is a non-separable, right? So here we are having an error, right? So we have to take it to a higher dimension to make it separable, linearly separable, right? Okay. Fine. So this was your SVM, support vector machines. Decision tree is another algorithm that again play a very critical role in supervised classification algorithms, right? It is one of the most important algorithm, right? So in this algorithm, what we do, this is a linear, this is a very simple approach again. What we do whenever we are having any random thing data set with us, what we will be doing, I will be creating a hierarchy, a tree I will be drawing, and accordingly I will be finding out that this input belongs to which particular class, right? So this is a tree, basically build a tree. Okay, so it is robust and builds a model in the form of a tree structure. Its grouping exactness is focused on different strategies, and it is exceptionally productive, right? So here what we are doing, we are building a tree. For example, if the age is less than 30, then eat pizza or not to eat pizza. Okay, so if you are eating the pizza, okay, then if the age is less than 30, okay, if you are eating the pizza, okay, then we are fit, then we are unfit. If we are not eating the pizza, then we are fit. Okay, and if we are doing exercise, okay, and age is less than 30, if we are doing exercise, then we are fit. If we are not doing the exercise, we are not fit, right? So in this way, tree-like structure is built, right? So here how it is built, it is very important. What we have to do, if we are having a data set with us, we have to identify the root node, the branch node, and the child nodes. If we know all the things, root, branch, and the child nodes, then we can construct the tree. And how it is done? It is done by finding out the entropy and the information gain. What I usually do, entropy is the impurity in the data, right? I find the impurity before the split of the data and after the split of the data corresponding to each attribute that I am having in my data set. And based on that, what I will do, I will find out the information gain, means the difference in entropy before the split and after the split. And जिसका information ज़्यादा से ज़्यादा आएगा, उसको मैं first node consider करता जाऊंगा, and accordingly I will split the data until the information gain becomes 0. Means if I'm having 5 attributes with me, okay, 5 attributes are your 5 attributes only. If I'm having 3 attributes only, for example, aptitude, communication, okay, and the and personality. And based on these 3 attributes, I want to find out whether the student will be given an offer to a company or not given an offer to a company. So based on these 3 attributes, I will construct a tree. एक ट्री बनाऊंगा, right? How I will construct a tree? I will be having a data set with me. ठीक है, your supervised data set, label data set मेरे पास है. So with that data set, I will find out the entropy. Entropy is minus pi log to pi, and I will find the entropy before the split and after the split, right? And I will find the difference between the entropies, right? And once I found out the difference between the entropies, I will find out the information gain, and accordingly I will see which is the branch node, which is the root node, and which is the leaf nodes, right? So in this way we can build a decision tree, right? This is the entropy of a decision tree, right? And information gain is difference in the entropy before the split and after the split, and accordingly I can formulate a decision tree, right? Random forest is another algorithm. It is again a very good algorithm. It is also known as ensemble classifier. Why it is so? Because it combines number of decision trees. काफी सारे decision tree को combine करता है random forest, right? And it does a voting. Majority voting जिस side जाएगी, that will be the final decision, right? So not constructing a single tree. In decision tree, we are constructing a single tree, right? In random forest, we are constructing number of small decision trees, okay, by separating the data into small sets. And based on that, at last, we do a voting, and the algorithm that is giving the tree that is giving us the number of trees. Voting करने के बाद हम लिखेंगे vote सबसे ज़्यादा किसको आया, right? The output that gains the maximum votes will be the final output, right? So this is the random forest where we are splitting the data into small sets. We are constructing small decision trees, and we are based on the majority voting where we are identifying that this belongs to which category, right? Okay. Now, in case of evaluation matrices of classification model, we are having some parameters, that is J-card index, okay, precision, recall, okay, log loss, okay. J-card index is, suppose we are having actual values and predicted values. A and B are the actual values and predicted values, right? So A intersection upon mode A plus mode B minus A intersection B, right? So here you can see that your only 8 values are same, 2 are different, okay. So 8 upon 10 plus 10 minus 8. 0.66. So this is J-card index, right? So this is used to find out the performance of a classification algorithm, right? It is widely used, okay, to analyze the performance of any classification algorithm. So here we are constructing your matrix. That is your suppose we are having 2 outputs, okay, positive and negative. Okay, actual value is positive negative, predict value is positive negative. अगर positive है predict हुआ true positive, negative है positive predict हुआ false positive. अगर actual है positive लेकिन predict हुआ negative, false negative. अगर negative है negative predict हुआ true negative, right? So here with this we can construct this confusion matrix, that is TP plus TN, true positive plus true negative upon true positive plus true negative plus true negative plus true positive, right? So based on this we can find out the accuracy of a model, right? If the output is 3, then the matrix will be 3 cross 3. If the output is 4, matrix will be 4 cross 4. So based on the outputs, output मतलब अगर जो मेरा output है, अगर students के marks हैं, I have categorized the marks as poor, good and average. So output is 3. So confusion matrix कितनी construct होगी? 3 cross 3. If the marks of students are good or bad, confusion matrix will be 2 cross 2. Okay, so in this way we can find out the accuracy of our classification model by constructing the confusion matrix, right? Okay, next is the precision, recall, F1, log loss. These are again based on the your confusion matrix, nothing else, right? Now, coming to the unsupervised learning. In unsupervised learning, we are basically learning without a teacher, okay? And we are having unlabeled data set with us, right? We don't know what is the output. We are only having the inputs, right? So clustering is the main algorithm that comes under unsupervised learning, okay? Okay, so here suppose this is a raw data with us. So based on this raw data, we have to identify based on the shapes that this is pyramid, this is cuboid, this is circle, right? So this is done automatically. Nothing is written that this is cuboid, this is circle, this is your pyramid, right? Automatically based on the features of the data set that we are having, you have to identify that they are lying in which class. Okay, so here we are working or we are playing with the unlabeled data set, right? Okay, so unsupervised learning versus supervised. In unsupervised, we are having labeled it. Supervised, we are having labeled data set. In unsupervised, we are having unlabeled data set. Supervised divides the data set into training and testing. It learns the unsupervised learns the association in the data set, right? In supervised, we are having algorithms classification regression. In unsupervised, we are having algorithm that is clustering. And in supervised, we are basically finding the posterior probability. In unsupervised, we are basically finding out the joint probability. Joint क्यों हम association find out कर रहे हैं between the data sets, right? Okay. So clustering is basically an algorithm that comes under unsupervised. Here we are building clusters in such a way that the items within the cluster should have the maximum similarity and they should have the minimum similarity with the items with the other clusters, right? So based on this, the clusters are being made, right? So here, suppose we are having a bucket in which we are having different items. So we are making clusters based on the color. We can make the cluster based on the shape. We can make the cluster based on their sizes, right? So these are the clustering algorithms, right? Okay, so there are three types of clustering techniques are there. K-means, hierarchical, or the density based. In the K-means clustering, we are basically plotting the data, okay, and we are basically finding the centroids of the data, right? So this is a data set. We are plotting the data. We are finding the centroids of the data. We are making the different clusters based on the centroid, and we are refining the position of the centroid in iteration by iteration until the centroids don't change. So these are the clusters that we have built in K-means clustering algorithm, right? Okay, this is a very simple algorithm. Fine. Okay, then hierarchical clustering. In hierarchical clustering, we are basically building a tree-like structure only. Okay, but here the clusters are being made in different ways. Okay, so we are either moving from top to bottom or bottom to top. If you are moving top to bottom, okay, so if you are moving top to bottom, it is known as divisive clustering. If you are moving from bottom to top, it is known as agglomerative clustering. Okay, so this is another clustering technique, that is hierarchical clustering. Okay, in which we are making clusters based on the hierarchical structure, right? Okay, the time is less. I have to move fast. Density based clustering is a clustering in which we are making clusters of arbitrary shape, right? Till now, the clusters that we are building in hierarchical or the K-means, those are the spherical shape clusters. Whenever we are building clusters of arbitrary shape, then we are using the density based clustering algorithm, right? So these are the different shapes of the clusters that we are building in density based clustering algorithm. So DB scan, density based clustering is basically DB scan. So here we are making clusters of any arbitrary shape, right? In K-means we are making the clusters of mostly of spherical shape, right? Okay. Last reinforcement learning, I have already taught you that we are learning from the environment, learning from the nature with reward and punishment. That is reinforcement learning, right? Okay. Now coming to the limitations of machine learning. Machine learning is basically having some limitations, right? Whenever we are having large amount of data with us, right? Or the data is of higher dimension. Okay, that is not recognizable by the machine learning algorithm. In that case, we are switching to deep learning algorithms, right? Fine. So limitation of machine learning is traditional ML algorithms were not useful while working with high dimension data. Okay, that is where we have number of inputs and output 100,000 or even more. Okay, so people call this the curse of dimensionality, as they observe certain ML may behave poorly when the dimension data set is large. जब data set की dimension ज़्यादा होती है, means whenever we are working on images, we are working on videos, okay, where the dimension is 2, 3, 4, 5, जब higher dimension है, there we are preferring deep learning algorithms, not machine learning. When the dimension is less, one dimension of data, right? Then we can go with ML algorithms. So when the dimension is large, we are going with deep learning algorithms, right? So deep learning algorithms comes to rescue this knowledge extraction, right? So deep learning is one of the only methods by which we can circumvent the challenges of feature extraction. This is because deep learning models are capable of learning to focus on the right feature by themselves, requiring little guidance from the programmer, right? So they are doing these things, knowledge extraction themselves, right? Okay. So that's why these deep learning algorithms are much beneficial as compared to ML algorithms in high dimension data set, right? So basically, I told you earlier that deep learning algorithms are inspired from neural networks, right? Neural networks are the neural network is the network that we are having in our brain. We are having millions trillions of neurons, and those neurons are connected with each other. Now uska ek chota version, okay, small version we have simulated in the software, in virtual environment, in MATLAB or Python. That is neural network, right? So those neurons are virtually created in the virtual environment, okay, and they are inspired from the biological neural network, right? Okay, and they are basically doing predictions or classifications, right? So as you know that human brain consists of neurons, and we are having receptors are eyes or ears, okay? They are taking the signal, they are giving the signal to the network, and effectors, we are our hands, our legs, they are responding in some way, right? So similarly here we are having this is your biological neuron, right, which is having synapse, dendrites, axons, right? So it is with this your artificial neural network is being inspired, right? Okay, I'm just giving you the idea of your ANN, right? Yes, this is the model of a neuron, right? Where we are having number of inputs, we are having synaptic weights, and we are having a summing junction where all the inputs are multiplied by the synaptic weights and they are summed up at this junction, and a bias is added to it, and thereafter the output is given to an activation function, and after that we are getting the final output. Okay, so this neurons, number of layers are there in the in the virtual environment, and they are basically learning the things and they are responding accordingly, right? Okay, so coming acha, yes, we are having number of activation function with us, threshold function. Okay, jo bhi the thing that we are getting at the summing output of the summing junction, that is being given to a activation function, which is either threshold function, in which the output can be either 1 or 0, or we are having piecewise linear function, which the output is 1 or it is the same value or 0 in certain limits, right? Function can be sigmoid function, Gaussian function, or ReLU function, right? In the ReLU function, the output is 0 if the input is less than 0, and output is x if the input is greater than or equal to 0, right? Okay, so how the neurons are connected with each other, okay, based on that we are having different architectures. Single layer neural network, in which we are having a single layer of neurons, okay. If we are having multiple layer of neurons, okay, multiple layer of neurons, then it is a multi-layer neural network. Okay, so based on the problem, if the problem is easy, we can use single layer neural network. If the problem is complex, we can go with multi-layer neural network. Okay, and if the network is having a feedback loop, then we can go with the recurrent neural network, right? Okay, so these are three networks that are the network architectures that we commonly see in neural networks, right? Now you have seen different neural networks. Now coming to deep learning, right? Whenever we are having two layers, okay, then it is known as shallow neural network. When the layers are more than three, which layers? The layers that are comprising neurons, then it becomes deep neural network. So you've understood now when to use machine learning, when to use deep learning, right? And second thing is, what is simple neural network? What is deep learning network? Simple neural network is basically when the number of hidden layers are two. Okay, fine. When the number of layers increases more than 3, then it becomes deep neural network. Okay, it will be more clear to you with this diagram. Shallow neural network, single hidden layer. Okay, when the hidden layers are 3 till 2, it is shallow neural network. When the number of hidden layers are 3, then it is deep neural network, right? Okay, so as recently updated by Wikipedia, deep learning is a branch of ML based on a set of algorithms that attempt to model high-level abstraction in the data by using a deep graph with multiple processing layers. And it is composed of multiple linear and non-linear transformations, right? So non-linear transformations are activation functions, right? So here we are basically abstracting the knowledge by creating a neural network that is having more than more than two layers, right? That network is known as your deep